since I started my own company here. I also serve as a liaison, or you can say representative for young professionals for Vehicular Technology Society of IEEE. So that is also something that is purely voluntary and quite nice. And beside that, since not all of us have access to latest information on technology and trends, so that is what I try to do. I try to post my vlogs and other informative videos on YouTube and Facebook, just to share or disseminate information as much as we can. So to begin with, we know we are living in an era where the technology development is really fast, and I bet no sector is immune to disruption. Business models have changed, boundaries have diminished. Like in the past, we saw that someone is bioscientist, or someone is physicist, or someone is mathematician. But now it is different. It has changed. So it's not like you just stick to one area. All the fields have, you can say, merged, and you need to know a bit of more than what is your actual domain. And by this, what is happening? We know the unicorn and mega tech companies are found in a very short span of time. So some of you may not know what is unicorn. Or a unicorn is typically $1 billion company that has grown up to, like, from nowhere to $1 billion. So these companies, before, it was very hard to get, but nowadays, because of these technologies, you just name a few companies and they overnight became unicorns. So that is the reason why it is important to understand what are the emerging trends in IT. And to the faculty members as well as to the students, it is equally important to understand which direction we are heading, so we can improve the education quality as well as our learning insight. Beside that, in the later part of the presentation, or yeah, I will discuss one more thing that we feel that is very important, is the study and scholarships abroad. Because I am talking to you, mostly the female students from the women university, and I know in Pakistan for women, it's not so many opportunities when it comes to abroad. Opportunities are there, but either it is lack of awareness, either it is cultural norms, or many other challenges. Female students do not travel abroad as many as the male students. So this is something that we are encouraging. We want our Pakistani female students to come abroad to study here and to really show what they are capable of. So this some of the hints and tips towards the end of this presentation I will share, like what are the objectives and what we are doing right now as a, you can say, volunteer or social work. So just if you stick to till the end, I think you will benefit from it. So I begin with the emerging trends. So I have gathered like 10 or 12 uh, trends or technologies. I cannot talk in detail about each of them, but I will give you some hint, and then we will discuss 5G and V2X as a case study. So many of you may have heard artificial intelligence or machine learning, and you may wonder what it is basically. So it's nothing new, in fact. The fact is that artificial intelligence, it's purely, or machine learning, it's purely mathematical statistical models. Sorry. Let me see. Yeah, here, yes. So what AI is really going to change the world. I think it's not exaggeration to say that it is really going to change the world in many ways. The way we understand our systems, the way we understand our processes, like in terms of image recognition, economic forecasting, banking, all these sectors will be disrupted by these advanced AI or machine learning techniques. And it is continuously improving and growing. And we know that human tech understanding will surpass. Something is wrong with these slides. They are changing by itself. Let me just see what is the problem. Sorry, just not sure. Anyhow, but so tech industry focus has been on automation. Hence, AI and machine learning engineers are already in high demand. So if you are studying IT, I think this is one of the area that I believe is of interest for all of you. We will look into more details very shortly. So then coming to Internet of Things. So Internet of Things means that we dreamt of a connected world and to make it to reality, like implementation of sensors, smart homes in the agricultural lands, automobiles, roads, health equipment, and the list goes on, are not only helping us improve our understanding of the system, but also enhancing our ability to control and automate them remotely. And in next 10 years, I'm just touching for next 10 years so you understand, like mega tech companies like Cisco, Huawei, Ericsson predict that IoT connected devices to be as many as 500 billion. Then it is the blockchain. You may have heard of cryptocurrency, and that is one of the application of blockchain. It may look very complex mechanisms, but the basic idea is very simple. In the blockchain, it decentralizes the storage of data so that the data cannot be owned, controlled, or manipulated by a central actor. It enables a transparent means to convey information and improve authenticity. So I mean, again, if we go in deep into each of these, we need hours for each of these topic. But what I want to give you an overview, like which of these trends where IT or information technology is applicable or relevant for you. So you know which areas to look into if you get any interest. Then it is 5G. That is my area I work with mainly. And what we are going to do with 5G, it is simply the fifth generation of cellular networks. By growing devices, like I said, Internet of Things will have billions of devices interconnected. We would like to have ultra reliable and low latency communication because we are now heading into the safety critical communication. We want autonomous driving cars around us. We want remotely conducted surgeries in hospitals. And all of these require a fast internet connection. Not only internet, but you can say a data connection where we could stream, where we could control things, and where we could disseminate information between different connected devices. And in order to achieve that, 4G is not sufficient that we use in our mobile phones today. And 5G is very much needed. So we are into 5G already now, and the discussions for 6G have already started. So this is another area that is huge and that has enormous application for IT. Then going to the big data. Big data is like we know that today the data is another oil where the companies are making money. For example, we have YouTube. We like let's say we use YouTube, Facebook, a lot of other social media applications, and all of these social media applications are keeping track of what we do. They keep track of what we search. They keep track of basically everything. Google Maps is tracking where we go, which way we take frequently. When we do the bank transactions, bank is taking saving all the information. You are studying in the university, your data is saved in the computer university central database where your exams, your marks, and everything is saved. Now, if you want to make some analysis of each of these parameters or variables, let's say we want to say that how many students in computer class pass every year and fail every year. And one statistic is for this university, then another statistics is for the whole country. So all of these end up into a big data, and how you make use of these, and then data processing applications and software, how you design all of this. So this is like, you can say, by digitalization, it's enormous data, and enormous data requires new mechanism to analyze, process it. Then we have another concept, that is digital twins. They will emerge, like that combine data analytics with real-time data to predict risk levels. So today, for example, if you analyze your medical history, a patient's record, you could always predict what is going to happen with the person in next 2 years or 3 years, or just to predict from based on their family history, if all of this is digitalized. Then we have cloud and edge computing. I mean, we spoke of 5G, we spoke of big data, we spoke of Internet of Things, and all of these need a shared space where this information is stored and can easily be accessible from everywhere. And there comes the cloud computing. And edge is basically to move, to do the processing faster, because if we want to if we have a cloud in the US, for instance, and we want to access data for each iteration from the US, it may take too long time. But if we have an edge computing server just next to GC University Faisalabad, then what you could do, you could have some local data that is more used in that localized area. So what you could do, you could just process it faster. You can access it faster. So you will have a virtual copy from your cloud into the edge clouds. Then we have sorry, renewable energies, because we speak so much about the environmental impact of these technologies, and how we are damaging our environment. So renewable energy is one of the way to reduce this impact. And that includes wind, water, hydrogen, and other natural resources to generate electricity. And that is also one of the area. And imagine if you want to control all of these wind powers or water stations, and again, this is an IT system. I mean, in Sweden, half of the country's electricity grid is controlled by two-person. Imagine, like, half of the country's electricity grid is controlled by two-person. One works at night and one works during the day. This is amazing because all the system is automated. So from Stockholm upward up to the north, it's a very long country. So they have made all these systems so much automated. What is happening? There are software guys and other people who are always improving these softwares, but the control is in two people hand. Quantum computing. Quantum is just the future. I mean, we are speaking of quantum computing systems, although it may seem a little bit futuristic, like from the movie of the Back to the Future, but it is not so far away. This picture that I'm showing, it's already a prototype from Stanford University and a couple of more collaboration partners where they are building this quantum computation machine. And that is another area. And here, I think what we know of IT today will change. What we know of processes and computation will change. So if we look a little bit further, 10, 15 years from now, maybe the things we are learning, they may not be applicable on quantum computing. And that means that this is something that requires further insight. So if we are someone who is interested in research, that can be an area where you could look into. Then going to the robotics. So I used to work for Volvo Cars 5 years, and quite often I was going to the plant, where the factory. And in the Volvo factory, we had more than like 2,200 robots. If I am not mistaken, if they have not have more in last 2 years, but let's say more than 2,000 robots, and each robot is capable of working as much as 4 persons at a time. They are so precise, they are doing all the stuff by themselves, and that's it. Doesn't end here. Now, when there was COVID in China, in the hospital they used robots to deliver food and medicines to the quarantined patients. There are robots in almost all the industries, like we speak of this industry 4.0. And again, this is a digital system, and in the back it is again IT system. So I mean, you are from the IT department, and I'm just trying to connect all of these, that how these, each of these domains, it may seem like you're not from the robotics department or control, but it is connected. Connected autonomous vehicle, this was something I was working on at Volvo, and it's still doing research on it. And I can tell you, like, it's $1 billion industry. Imagine, like, I will explain more in next slides in detail what it is, but just think of it as that all the cars, when they will be communicating to each other, they're already doing that. I mean, many cars here, for example, here in Sweden, we have lots of snow. So cars get data about the snow, slippery road conditions, and other warnings already into the car directly from the cloud. There are more things coming in that I will explain in shortly after a few slides. Then food and agriculture. I mean, you must wonder what is related to IT in food and agriculture. I mean, we are going to the smart farmings. Smart farming have everything controlled, digitally controlled from the control rooms, and then that makes it an IT system again. That when we are speaking of improving the yield of the our fields, we want to cultivate the things that are not according to the season in the controlled forms, and all of these things require digital system, and digital system then is relying on or interconnected with the IT systems. We speak of augmented reality. Augmented reality is like virtualization. So if, for example, you are sitting in Faisalabad and I'm sitting here, and I want to control something in Faisalabad, like you have some tool and I want to give instructions from here. So what I could do, we could have some augmented or virtual reality that enables, I touch the object in spaces, and then you look at it in your VR there, or vice versa. So all of this, and this is also another kind of interactive approach. And this is a perfect example now when we have COVID situation, that many companies cannot, people cannot travel, many organizations, they are facing problems. So this is a perfect thing for to have such a technology. So with that, I mean, I have tried to list few of these technologies. I mean, there are tons more, but the reason of having these is that you can see that how broad your subject is, and how many things or how many domains you can switch to. I mean, if you're doing BS in IT, you have like whole world open to you, and you can just switch to any of these domain if you are planning to do MS or PhD or your job. So here you can connect all of those, that how we are using those technologies. So imagine a modern city, and that city is like, it has hospitals, it has a hotel, it has let's say some park, a hospital, I said, like I said, some industry or factory, some office area, and other residential buildings. So what is happening? If we want a self-driving car to go, that is that requires connectivity and onboard sensors. And inside the vehicle, I mean, the last model that I used to work for at Volvo, it has like dozens of processors inside. Like you can say dozens of computers, more than 50 and 70, depending on what model you are saying. It has more than 30 sensors around, like on the car, that includes camera, radars, lidars, and many other. Similarly, a new car may have between 10 to 20 antennas on it, and you must wonder what it is used for. It's like for different positioning standards, for 2G, 3G, 4G technologies. Soon it will have 5G. Then we have radio antennas, TV broadcast, and so forth. It's so many things. Then we are going to a hospital if there is a patient, and we have e-health application where a person wants to do a surgery remotely. A doctor wants to do a surgery remotely. He is not available in the city. So then we may have this possible when there is 5G. Then we are talking about like gigabytes in second if we are in a residential area or in an office environment. What is happening? We have like enormous amount of data exchange. We are watching 4K or 8K videos. We are playing HD video games and those things. And then we are expecting gigabytes in a second. We have augmented reality. I mean, like we had Pokemon Go and those applications, and kids are playing those games. And what we want, we can have VR with all of those. I mean, this is just a depiction of how the modern society may look like. I mean, it is not necessarily that it is good or bad. We don't go to that discussion, but all of these things will happen, not so far from today. And to connect all of this, what we need a fast communication system, and that is where the 5G comes into play. Like any of these systems we speak of, either we have wired connection or wireless. And when it comes to wireless, then it's the fifth generation. So then we say why we need it, what is the benefit, and how we are going to use it. So let's look into it. So why do we need 5G? Because we speak of connections. Connections means that billions of connections. We are speaking of in one report recently there was that soon we will have our 50 billion connected devices around the globe. Imagine we are just under 8 billion people on the planet, whereas we have our 50 billion devices already. Just take an example. Now you around you have a laptop, maybe one or two mobile phones. And then here, if you come to the West, then you may have many sensors at home: fire sensor, home security sensors, and those things. So all of these devices need a connection, a secure connection, a reliable and fast connection. Then we want latency. We do not want too much lag in the call. I mean, you may have heard a lot people saying, "Do you hear me? Your voice is breaking," and so on. So, but you cannot afford this when you speak of safety application. By safety application, I mean if there is a fire and people in or the fire brigade people are tracking their colleagues inside a building where there is a fire, they cannot afford a lag. They want to monitor each and every step. So if someone gets stuck, they can send the backup. If there are cars communicating with each other, they need a millisecond latency. They do not want to crash and then send a message that I'm going to crash. I mean, then it will be too late. And there are many other applications like that, or even the remote surgery, for instance. Then we speak of speed. We are speaking of gigabytes per second. And gigabytes per second, it may seem unrealistic today, but it will be needed. Let's say we already have 8K TVs at our home. We are already playing games that consume enormous amount of data. Today we are using Ethernet, but take this into your cars. I mean, if you have a self-driving car, what will you do? You will not. If you just sit and don't drive, you will be bored. What you maybe you want to work in the car, maybe you want to watch a movie or do whatever. So A lot of these, I mean, it is hard to imagine this, but it is going to happen very soon. So this is the reason why we need 5G. Then we go, what is happening here? This is from the IMT advanced 4G versus IMT 2020. So IMT is the institute, International Mobile Telecommunication Institute, that set the requirement. So it's requirement in a way that if you are at the university and your university is setting the requirement for teachers that you need to teach that many courses this year, and for the students that you need to take this many courses, and to pass you need this then this much numbers. Just like that, for the telecommunication equipment, this institute sets the requirement that with the 4G, oh, look at this inner web. So this is what 4G could do. For example, peak data rate was 1 gigabits per second. User experience 10 megabits per second. Spectrum efficiency 1 times. Mobility 350 kilometer per hour. So now IMT stretched all these limits to tenfold, twice, or I mean different scales. So now with 5G, we want 20 gigabits per second data rates. What we want network efficiency 100 times what we can afford today, because we are expecting that much increase in the devices. Similarly, we want as low as 1 millisecond latency, like 1,000 times of a second. So that's like really low latency from end to end. So all of these limits or requirements were pushed, and now what we are doing, we are trying to achieve this when we are designing the 5G system. So incremental, and to achieve this incremental evolution of 4G system was not sufficient. A 5G system with fundamentally new technologies and paradigms to complement ongoing evolutionary trends is needed. Now you may think that, I mean, this is okay, these are requirements, but what it has to do with IT? So think, what is 5G? 100 billion connections, let's say 1 millisecond low latency and 10 gigabits peak data speeds. So that is what we say, we summarize 5G to. So here I connect these requirements to the services. And when you will look at the services, then you will understand, oh, this is again the IT systems. So we spoke of peak data rates, we spoke of user experience, spectrum. Mobility is like how fast you are driving in the train, in the car, and you still have the best access. Latency, connection density, all these KPIs. And if you look at these charts, they are relevant to different application set. So one application set is enhanced mobile broadband that requires high data rates. Then we have massive machine type communication that drops down to industrial IoT, industry 4.0, that is the next industrial evolution. We have these agricultural applications and those things. So all of these fall into massive machine type communication, because there we speak of connection density mainly, and network efficiency, because if too many connections, then we need to make them efficient because the resources are always limited. And finally, we go to the ultra reliable low latency communication, because there we talk about smart cars, fast mobility. And with fast mobility, I mean, the faster we move, the less time we have to respond. So that is why these factors are very relevant here. I mean, if we are transferring a data file, if it is 1 second delayed, maybe it is not as bad as 1 second delay before the crash. So we need to see which is relevant here. And then what services these are connected to. So like I said here, low latency, self-driving car, industrial automation, this is the domain here. Here we speak of smart city, agriculture, and those smart buildings. And here we speak of 3D and HD. So all of these are IT systems. I mean, in IT is in Pakistan. Usually, I must say with sorry that in Pakistan we have really killed the IT. I mean, we have made an IT into something that is not really an IT in the rest of the world. I mean, our IT engineers often do not know how to program. Our IT engineers do not really learn the system. They just learn very high levels. You can say the specifications of the system, but they really do not get into how the system is designed, how the systems could be improved, how the systems could be controlled or monitored. And that makes a lot of our IT engineers useless. I mean, this is I'm saying it just from my heart, because I have seen this happen. I have seen many students applying here. They don't get jobs just because they do not develop interest into programming. They do not develop interest into design. They do not develop interest into software architectures, and all of this is really needed. And one thing that I know in Pakistan that we are facing this problem, we do not have a big industry. We do not have big, you can say, the IT industry that really supports students. So it's like it goes both hand in hand. So I mean, it's not only the you can say the university fault or student fault, or I think it's coming from all directions. So, but I mean, we are unfortunate we didn't develop this industry. But I just want to give you this that if you really want to go abroad or to really excel in your career, just keep this in mind. Without programming, I mean, you are not going anywhere. You may just find a job with luck or with reference, but you're not going anywhere. So this is something maybe not really a good news, but that's how it is. So who is interested in using 5G? I mean, we have different players that are already very active to low active. So very active means the broadcast and media industry that is already very much active into this. Then public safety. Then we have some like education, automotive, and rail industry, and present utilities, healthcare, and aeronautical. Like we speak of drones-based deliveries, and those. Health is like if we want to monitor our health remotely or in the devices. And then Industry 4.0, agriculture, and mine exploration. So all of these industries, you see, I mean, sometimes we look at mine exploration and what we say, like, what do we have to do with IT? No, I mean, this is something that will change. Agriculture, I mean, we used to look at our grandparents and they were going to the fields, but it is not like that. Now the farms are really they throw robot sensors into the farm that give data which part of the soil is properly wet or not, which part of the soil is getting all the fertilizers and not, and all these sensors are taking these measurements, and if somewhere it is low, then you quickly know, okay, here the fertilizer is not sufficient, so I need to do something. So this is really amazing to look at that all these industries are changing, and which creates more opportunities for you. That is also best. So this is to summarize, like, in short, what is 5G? A platform for disruptions. We speak of new applications, new business models, new industries, and just enabler for disruption. That the way we think of the world will no longer exist. It will change, and that is why you see a major like fight between countries over 5G, because they know what how important it is and what it really worth. How we can get to 5G? Open collaboration across industries, that is what we do in everyday work. Heavy investment in technological innovations and evolutionary commercialization strategy. So I mean, these are the ways forward, and that is how the world is working to get to 5G. Okay, so we spoke of 5G. Now we go into another interesting application area, that is V2X, or vehicle to anything communication. I mean, I am working on this since 2007. I mean, it was very immature technology by then, and now soon, let's say, by end of next year, we may have a couple of car companies already having. In fact, Volkswagen Golf already has this technology this year. So what it is? When all these entities on the road are communicating, for instance, cars communicating to cars, car like cars communicating to infrastructure, cars communicating to pedestrian and cyclist, and communicating to network. So, and then you may wonder why it is needed. Why should they communicate? So first we know that okay, V2X is when vehicles are communicating to all the road users, and a complete road safety and traffic efficiency solution that allows vehicle to communicate with. So this solution we speak of that allows it to make the roads safer and efficient. And how it is going to happen? Before we go further, just know that when I say vehicle, that means that bus, ambulance, car, truck, all these motorized vehicles I speak of. When I say vulnerable road user in the future, that means pedestrian, cyclist, scooter, disabled, elderly, all those who are not in the motorized vehicles. And when I say infrastructure, then it's the smart traffic lights or road signs. So this is just the combined abbreviation. So what is happening now? Today, when we have, let's say, a smart car, it has onboard sensors, maybe 20 to 30 sensors on the car. And as soon as something comes in front of the car, you may have seen like the car has radar, and as soon as something comes in front, it brakes. So it doesn't collide with that object. But if that object is hidden behind the wall, then it is not possible to see. But what we could do, we have a mobile phone in our pocket, for instance. So if the car can communicate to the mobile phone, or mobile phone can inform the car that I am heading towards you, be aware, then we are into this screen. So V2I or V2V, like vehicles, when vehicles behind the walls or person behind the wall communicate to another vehicle to inform that now you cannot see me through your sensors, but I am here and coming towards you. Then what happens? It warns it, and then the car takes precautionary measures, that it reduces its speed, or it really checks which direction the person is coming and it doesn't hit that person. And if we go a little bit further, where we have information zone, that is where vehicle to network comes in. So let's say 3 kilometers or 2 kilometers from where you are driving, there is a slippery road. There is a lot of snow and this road is slippery, or some accident happen and then you are heading in that direction. Today what happens, we get into that traffic jam and then we know, oh, there is an accident, then we have no way to go out of it. But if we get through the network, mobile network, this information that no, you should not go into that accident area, and you are suggested a different route automatically by the car, then you are basically improving the efficiency of the system, or on road usage, because then you are not getting stuck into the traffic, you are not getting on the slippery road. So a lot of these benefits we speak of, we have here: act, warning, and information. And that is what we want to achieve with this green zone, where vehicles will be talking to each other. For that, we have different standards. And why I'm saying this, or I'm trying to explain this, because again, this is all of it in ID. I mean, inside the car, we have hundreds of ECUs, and these ECUs need softwares to communicate. These ECUs need some kind of databases. So we have like ad hoc short range communication, and we have a long cellular network, a long range communication. So we divide. When we are locally communicating, we use this standard PC5, and we are communicating long term, then we use cellular network. And this is exactly like now I work on that, how 5G can be used for these standards. So cellular based V2X, CV2X PC5, that is a new standard that we are developing, and this is an old standard I used to work before. And here we speak of, like, we have two alternate choices. And when we speak of mobile edge computing, all this data that is communicated here, it is sent to the edge clouds through the mobile network. We have parking lots, we have smart car homes. For example, if you have a car, it is going towards home and you are in front of a garage door should open on its own, then that means that you are communicating to it. Or you want to turn on some of the lights at home as soon as your car arrives. That means that when the car is in the proximity, it knows now I am closer to home. It already turns on some of the lights. And in some countries where it's too cold, like in Canada or north of Sweden or Norway. Speaking of V2 extenders. Oh, sorry. Where is it? Let me see. Speaking of V2 extenders, what here? Yeah, sorry. So then, these are some of the basic applications that I would like to mention. That I spoke of these collision avoidance applications. So when you are changing the lane, maybe there is a scooter coming in, so you miss out that scooter because it is in the blind spot. It may come and hit you. So that's like one thing. Or something happened and this car hit the emergency brake, and that means that you are going to crash. So emergency brake, electronic brake light is one of the applications. And there are many different applications. I will not go into detail of all of this, but like when you are turning, a lot of accidents happen when you are turning left or right on the street crossings. So you want to avoid that because sometimes the motorcycle is coming from the front or the car, and you miss out, like you just have another car in front of you and you don't see it. We burn a lot of fuel. Many of you drive cars, and we know, like, when the signal is about to turn red, we just accelerate fast. And when we accelerate fast, we make one mistake, that we burn a lot of fuel, and sometimes we are not successful. We have to stop in the end. And to avoid that, we have a new application that is called GLOSA, Green Light Optimal Advisory application, and which tells you, because then the signals will be smart, it will tell the car, drive at this speed and you will always get a green signal. So then basically, in principle, you don't need a signal at all. It's just a wireless signal in a street crossing that, okay, here, if you are in this crossing, just drive at this speed and all the cars will be controlled just like that. Stationary vehicle warning. Sometime a car is broken. It has some maintenance issue on the motorways, and when we are too close, then we see it. But with the new technologies, we will know in advance that there is a car parked, so you just drive carefully, and so forth. You may think that all of this is futuristic and may be too far away, but to your surprise, I have gathered some of the slides or pictures. Many of these seminars, or many of these, you can say, demos, I personally attended. For example, this June 2018 in Paris, I was there. Then October 2020, I was there. A lot of these, and they have real cars that can communicate with each other, that can perform all these applications, and they are working perfectly fine. The reason why they are not on the car or on the streets is because for the new cars, there is like a lead time of 4 to 5 years. So if something is decided today, it may come in 2023 or 2024. So the new cars that we will see on the road equipped with these new technologies may start to appear from 2022 and onwards. So you see, like, all parts of the world, like US, France, Germany, China, Italy, all of these countries are doing the demos in collaboration with many different industrial partners. So this is amazing. Then again, because since you are from IT and I want to connect everything back to IT, so just want to show you that when we speak, I spoke of big data, I spoke of AI and machine learning. So here comes that thing. We speak of network slicing. Network slicing is like, For example, uh, in the universities, sometimes we have a staff room or a room or kitchen for the or like sitting area for the faculty. We have a student room or sitting area for the students. So why we need this kind of distinctions? Because the faculty is often quite occupied and they need some silence to prepare for the next lecture. They need to rest for before the next lecture. So they need some, you can say, some special area. Whereas for the students, they are bored in the class sometimes, or they study hard and they get tired. So what they need some place to talk to their friends, and then just talk about anything, about the games or about the series they watch. So they have different kind of requirements, the faculty and the teachers. Just like that, we have different applications and they have different requirements. Now in the mobile network, we want to create slice, or just like I said, the rooms for different applications, and they make accessibility different for different applications. Some applications require too high best treatment, then we give one slice of the network to those applications. Some applications do not need special treatment or do not have strict requirement. We give another kind of slice to those applications. And all of this will be controlled in the mobile network, uh, or the core network. And that is back in the back connected to the internet. So again, all of these control centers, mobile network, mobile operators control center, all of this is IT. So here, I mean, you may like think that it is not directly related, but indirectly, if you dig a little bit deep, this is something that you can do and you are going to do in future. Edge computing, when we speak of cloud, how you store data, how you read out data. I mean, we need hardcore computer programmers that write the programs. We need hardcore algorithm writers who write algorithms. We need software architect, and then we need IT engineers who are basically, yeah, you can say, the managers for all of this. So we have different role for each of these systems. And again, this is where you have your application. Edge computing, like I said, we have a cloud that is a central cloud, and then we want to bring some data closer to the user, because then we can access that data faster. Unicast, groupcast, I think this is a little bit too technical for the V2X. I mean, here basically we have different platooning applications. Not in Pakistan, it is done in that way, but a lot in the West, where we have big trucks, convoys or fleets from one company delivering products to another. In Pakistan, they do it, but it is done in a very dangerous way. For example, when you may have seen on motorway, the trucks are driving too close to each other, and the reason is very they want to save fuel. When they are driving too close to each other, the air drag to the front truck is high, but the trucks in the back is low. So what happens, they save a lot of fuel, and when they are driving compact to each other, they create too much empty space on the roads, so other cars can use it. But since in Pakistan, all those trucks are quite old and they do not have these smart sensors. So if God forbid there is one mishap, like front truck breaks in emergency, what could happen that all the trucks in the back may crash into that. But by these new technologies, we can avoid that. We can have radars on the trucks, and they can communicate. Or so that is where this group cast can come into play. And unicast is when there is an emergency vehicle like the police or ambulance coming on the road, then it can send direct signal. And so these are different applications. Like I said, how different part of the world are treating these new technologies and how this is so. I mean, you don't see Pakistan or India or these other Asian countries here. The reason is that this technology is hardcore research technology. I mean, in the research phase, also some development that we will see soon. But I think these are early adopters. and ours, these underdeveloped or developing countries, they are late adopters of the technologies because our road infrastructure is not ready for that. So maybe some of these systems, for especially for V2X, you may see happening in other parts of the world already in 2 3 years, but in Pakistan or India or these you can say South Asian countries, it may take a little longer than that. Yeah, again, in the US, many car companies are seriously focusing on it. In Europe, a lot of car companies and cities are focused on this. So, I mean, this is just to show that how fast or how much interest is there when we speak of these new technologies. These are European funded projects. It's billions of rupees funding on these projects. I was personally part of 5G Car and 5G Croco, and other projects are still ongoing, like 5G Carman is ongoing, Mobix is still ongoing. So a lot of these projects, and they are doing proof of concept across Europe on the European highways. Uh, So here is some timeline that I wanted to show. I mean, this is all I want to show, so you get the feeling that it's whole world open to you. You have a lot of different opportunities. You just need to keep studying, explore, and find the way out, because it's not only the things that you study in the book. This is just to learn you to walk, and then you have it is up to you how to run. So that, and the whole world is just open to you. Then we have this timeline from 2018 to 2029. So you see all these applications that I mentioned, they are going to be deployed in different years. So traffic efficiency applications, safety, advanced safety and automation, advanced safety automated driving, step 1 and step 2. So this is how things are planned. You see 10 years ahead or 11 years ahead of time, these things are planned, and slowly, one by one, these applications are introduced into the market. And 5G is going to play a vital role. And this 5G AA is one of the association. This 5G for Automotive Association is one of the largest association across in the worldwide that is monitoring or supporting V2X development. Uh, I will take questions later on. So you saw that in the beginning I mentioned something that for the study and scholarships abroad. I mean, this is something we felt very badly in last few years. Like we are sitting here, how we can help or support our country, and this was one of the way we thought that we can help our country, is that we help students to find opportunities abroad so that they can get admissions in the foreign universities, they can get scholarships in the foreign universities. And one of our main you can say target is to encourage our female students, because we have sisters at home, we have our daughters, and we want them to excel in their career. So that is why it is very important that our females are also making use of these opportunities. Not only the male students go and study abroad, but also females should go, and that is what we are trying to do to help. That we have this YouTube channel. What we do, we invite really you can say experienced guests who have PhDs, who have a lot of international experience in different countries. Like we have covered Norway, Sweden, US, Australia, uh, Finland, Denmark, a lot of different countries we have covered. We have tried to explain a step by step process, how you apply for admission, how you apply for visas, what do you need, what type of documents you need, how to get them attested. And then once you have arrived to these countries, how to find a job, how to find a PhD position. And a lot of these things, I mean, we are trying to encourage or trying to fill the gap where people do not have this information. Most often students do not know where to start, and that is what where we are trying to help. This is our initiative purely to help, or it's, you can say it's a give back to the society or country, and that is what we are trying to achieve with this effort. You are all welcome to write your comments, questions, and I mean, you just tell us what kind of information you need, and we will try to bring this kind of guest, or if we can find this information, and we bring it to you, because this is the area I think where our country really needs some support, and it has a lot of potential to do things in a very good way. So that is something I just wanted to show. And here, if you look at it, I mean, if you go to this, you will find the playlist and all these. I mean, it's a lot of information. It's hard to tell here. So I mean, we have many questions here, or so I would like to request Miss Suneza to please. I will stop sharing my screen here, and if she can just get some of the questions, and we can take those questions in last few minutes.
So thank you